Hi, I am Rajit, studying second year ECE in VVIT College, Nambur. Today, I will be presenting on the topic called random variables. Okay, the main reason to choose this topic because it is a very important part of probability and statistics, and it is widely used in engineering and real life examples, signal processing, signals and systems, etc. With this presentation, I hope to explain the topic in a simple way so that it becomes easy to understand for everyone. Okay, now let's start this session. Okay, in this session, we are going to discuss about what are random variables, condition for a function to be a random variable, and classifications of random variable. Okay, before going to the actual topic, let's discuss about some basic terms. Random experiment. It is an experiment or process that which all the possible outcomes are known, but cannot predict what is going to be happen. Right. For example, consider tossing a coin. We know that all possible outcomes are either head or tail. But before tossing, we cannot say which certainty will occur. Similarly, when we roll a dice, the possible outcomes are the numbers 1 to 6, but we cannot predict which number will going to occur when actually we roll it. These experiments are important in probability because they help us to study and analyze uncertain situations in scientific way. These random experiments are used in real life, such as predicting weather, testing machines, analyzing communication signals, and even in quality testing of products. Okay, here we can discuss about one more example. Tossing a coin, which is both-sided head. Then the possible outcomes are only head, whether we toss it when we toss a coin. So we cannot consider this one as a random experiment. Random experiment. Okay. Next is sample space. Okay. It is nothing but a list of all possible outcomes of a random experiment. Okay. For example, when we toss a coin, the possible outcomes are head and tail. Those are the set of head and tails are considered to be a sample space for the event tossing a coin. Similarly, when we roll a dice, the possible outcomes are 1, 2, 3, 4, 5, 6. The set of these outcomes is a sample space for the rolling a dice event. Similarly, when we toss two coins, the possible outcomes are head, tail, head, and two tails. Okay. The set of these possible outcomes are said to be sample space of the event tossing two coins. Okay. And next we discuss about sample point. Sample point is a single element in the sample space. For example, when we consider an event tossing a coin, the number of possible outcomes are head or tail. Okay, these possible outcomes are represented in sample space. So each element in the sample space are represented by sample point. And next, random variable. Random variable is a function that assigns real number to each point in the sample space. Okay, for example, with roll a dice, the possible outcomes are 1, 2, 3, 4, 5, 1, and 6. Okay, the elements in the sample space are assigned to a real number with this random variable. It is denoted with x. By and seeing with an example, you can better understand about this random variable. Let us see the example. Let x be the random variable that represents the number of heads and two coins are tossed simultaneously. Here, the random experiment is tossing two coins. Okay, when two coins are tossed, the possible outcomes are two heads, head, tail, head, and two tails. Okay, which is nothing but our sample space. Okay, here the random variable x represents the number of heads when two coins are tossed. Okay, from this we say that the random variable x consists of 0, 1, 2 from the sample space. Here the number of heads are 2 and here one head. Here also one head and here no heads. So this represents the number of heads in which x1, x2, x3 are the random elements of the random variable x. Okay, let's discuss about condition for a function to be a random variable. First one, unique mapping. It means every outcome in experiment should be only one value. For example, if you toss a coin, the outcome head may be given the number 1 and the tail 0. But we cannot give two numbers for the outcome, like head equal to 1 and head equal to 2. So each outcome must have a single value, single unique value. Okay, next one is boundary condition. This the value we assign must lie within the real number system. That means it can be number from minus infinity to infinity. This condition makes sure the random variable is well defined and can be used in probability calculations. Okay, coming to the third one, event formation. Finally, we have an event formation. The random variable should allow us to form events like x equal to 2x less than or equal to 4, etc. For example, if x represents a result of rolling a dice, then the event x equal to 2 means the dice shows 2. The x the event x represents less than or equal to 4 means the dice show 1, 2, 3, or 4. Such events must be possible in the sample space. This is important because only then we calculate probabilities like probability of x equal to 2 and or probability of x less than 4, right? So in short, a function can be a random variable only if it satisfies these conditions, which is unique mapping. Every outcome has only one unique value. Next one, boundary condition. The value is within real numbers, that is minus infinity to infinity, and it allows us to form valid events to calculate probabilities. Okay. Okay. Now let's see how random variables are classified. Random variables are mainly classified into three types. Okay. First one, continuous random variable, discrete random variable, and finally, mixed random variable. In the next slides, I will explain each of these one by one with examples. For now, just remember this is the basic classification of random variables. Okay, now we will see the first type of random variables, which is continuous random variable. A random variable is called continuous random variable if it takes the uncountable infinite values over the interval. This means between any two values, there are infinite many possibilities. Okay, for example, the height of the students in a class is not fixed at a whole numbers only. It can be like say 165.3, 160.35, like that. So we cannot say the limits for this. Okay. Similarly, the time taken to complete a task by a set of students, or someone takes 12.4 seconds, 12.45, like that. It is not discrete. It is continuous. There are many infinite number of possibilities between these. There is no end to show. There are no end how small we can go. Okay, this means there is no end between two numbers we can go to many infinite possible values. So how small we can go? There are many infinite possible values. The temperature in the place also comes in continuous manner, like 29.5 degrees, 29.55, okay, so on. That's all about continuous random variable. So, in simple words, we can conclude that a continuous random variable can take any values within the range. We usually represent if we use a curve called probability density function, which gives probabilities for intervals for not individual points. Now discuss about the second one, discrete random variable. Okay, a random variable is called discrete random variable if it can take only finite or countable infinite values. This means the possible values are separated and distinct, not continuous. So the sample space is made up of only individual points like 0, 1, and 2, so on. So from this we can say that only the discrete values are present in this discrete random variable. Okay, let's give some examples. In tossing a coin, the random variable x can take only two values, which is 0 and 1. Okay, similarly, in a rolling dice, random variable can take only six values, with 1, 2, 3, 4, 5, and 6. Okay, the number of customers coming to the shop in 1 hour can be counted in 0, 1, and 2, so on. Like that, in short, we can conclude that the discrete random variables use outcomes that can be counted only one by one, unlike in continuous random variable, take values from a full range. Okay, so finally we can say that the random variables Discrete random variables consist of only distinct points and finite values, as we can see in the above examples. Okay, now let's talk about the mixed random variable. A mixed random variable is one that contains both discrete and continuous parts. This means that some of the probability is concentrated at specific points, like in discrete case, and the rest is spread over the continuous length, similar to the continuous random variable. For example, imagine combining two things. First one, tossing a coin, okay, which gives only discrete outcomes like head or tail. And second one is measuring the height of the students in the class, which is a continuous random variable as we see earlier, right? Today, this makes a mixed random variable since it has both countable values and a continuous range of variables. So, in short, mixed random variables are defined as just the combination of discrete random variables and continuous random variables. Okay, and this is very important because these are used in real life applications. That's all. Okay, with this, I conclude this discussion on random variables. Okay, first, random experiment, a process where the outcome cannot be predicted with certainty in advance. Sample space, the complete set of possible outcomes of a random experiment. Next, sample point, a single point output from the sample space. Random variable, a function that assigns numerical values to the output of the random experiment. Okay, finally, classification of random variables. There are three types: discrete random variable, continuous random variable, and mixed random variable. Okay, thank you for your attention.